Hello all. This is going to be a lengthy tutorial, mostly in part for my professor for senior design and my GTA to run my code, but in general, more for anybody else who wants to do something similar. I'm going to go through all the pitfalls, problems that I ran into along the way that were challenging to find solutions on the internet for, or workarounds, or things that aren't necessarily clear, and or just spread out all over the place for several different topics. I'm going to cover how to build a flight simulator linking MATLAB's Simulink to Flightgear. To get started, I'm going to go through Flightgear and what we need to do for Flightgear installation and setup. Here we have Flightgear website. It's a free to download open source flight simulator, as you can see here. Just download the most recent version. It used to matter up until a few years ago what version you had. It no longer matters. Just get the most recent one. And when you do, go ahead, download it, install it. I'm not going to go through that process, but there are several things we need to do once you have it installed. So go ahead, pause the video, download, install it, and then come back and I'll go through next what we need to do. Once you have it installed, you're going to have your folder. In this case, mine is in my D drive, program files, flight gear, data, aircraft is what we're looking for. Here I have our team's custom model that we built. If you want something similar, what you can do is Simulink has this file here, ASBH ASBHL20. That's for the HL20. And if you just type this in, control copy, paste it in here, and hit enter, it's going to pop up with a bunch of files. And you can go through the installation process. You can find that on YouTube, how to install the model files, but that will pop up here as HL20. And if you go in here, this has the bare minimum of everything you need. So when you want to build another additional aircraft, similar to what my design team and I have done, I started with the base model of the HL20 and basically renamed, and I'll go through the renaming process of all the things you have to do, the model file, sounds, etc. So once you have your item downloaded, once you have Flightgear downloaded and installed, you'll need to copy and paste in the folder called aspiration into your aircraft folder. And we'll just go through some of the important things in here. Here we have the XML file for the aircraft. So if we go ahead and take a look at this, some of the things that have to be changed in here is going to be, if you want to like change the name of what the splash screen has, go through, you can change the name. This is if you're doing your own custom aircraft. If you're using the aspiration model, you don't need to change anything. So you would change any place where it has the aircraft name, you need to change it to your name, the aircraft that you want to custom build. Going into models here, Here's the aspiration.xml. This is going to work in tandem with the aspiration.ac. This is the AC3 file. This is the model, the CAD model that Flightgear will use to render the aircraft in Flightgear. So if we go into the XML file here, this is where you would put in any animations. So here we go. We have most of this, again, you can just copy and paste from one of the other aircraft if you've downloaded, or from this one, and you can go through and edit. Where you see this here, this is comment out for a block. This is the start of a comment out. This is the end of a comment block. So that this all here would be all commented out. And I do that for a handful of places. For example, our spacecraft, I did not put any compression in for the landing gear, so I commented out the HL20's compression for the gear. So here I have the animation. I changed the center and axis for our spacecraft to make it relative to where our positions are. And I'll go through again this later when I do the blender to Flightgear component. But you can see you have to go through and you can comment out things or edit to match your spacecraft or aircraft, whatever you're doing. We got some elevator, ailerons, rudders down here. So this is the XML file. And so you'll want to make sure that that's named the same thing as the model itself here. So once you have Flightgear installed, like I said, you want to copy in the aspiration folder into your aircraft folder. That will allow you to find it, Flightgear to find the model. Next, when you're building a simulator from scratch, you will generally need to have this. This is an old project I did. There's two ways to output data from Simulink into Flightgear. This is the easiest, and this is purely visualization with no animation. Here we have latitude, longitude, altitude. I might have had those first two backwards. Phi, theta, psi. So this will take in, longitude for L, latitude for mu. And this will send to Flightgear here, basically telling Flightgear, put me at a position, let's say here, pointed up in this direction, for example. And nothing more than that. There's no animations. You can't move. You can't interact. Very, very simple, very straightforward, very fast and easy. The slightly more complicated way is this method where we use the output block where you can specify parameters. For example, elevator, rudder, nose gear, landing gear. You can warp time, visibility for like range for rendering, how far you want flight gear to render, distance, scale, etc. Those various aspects. So this is the slightly more complicated way. You have a bit more control. Again, it is still driven, you'll notice, by these main inputs. Longitude, latitude, height above ground, phi, theta, psi. So it's still just being visualized. You just have a bit more control with visualization as far as animations here and gears, and you can apply a speed brake, you can apply gear brakes or raise and lower gear, etc. So over here we have this genfgrun file, and this is part of the Aerospace Block toolset. You'll need that to run any of this. So once you have the Aerospace Block toolset downloaded and installed for Simulink, you would generally have to put this file in. You just drag it in, you double click it, it opens up here, and there's going to be a few tabs here. All this stuff you set in here, this right here is going to dictate when you open Flightgear, and I'll show you how to do that in a moment. It basically just tells Simulink, or rather Flightgear, where to start you. It will have nothing to do when you get over to here and you go ahead and run the simulation. You're going to teleport. So it's quite irrelevant what values you put in here, because as soon as you hit run here, it's what values you're sending through this output block that's going to warp you and teleport you to whatever location you have dictated here. So this is fairly irrelevant. You can just leave all this stuff pretty much. The one thing that does matter is what you have typed in here. This block here will call over to Flightgear, and it's going to, whatever name you put in, the GB, Concorde, C-130, that is, it needs to match whatever folder name of the aircraft you want to run. For running the aspiration, you don't need to worry about any of this. This is all pre-built, and I'll show you that in a few minutes. If you're doing this because you're building your own aircraft, then we can skip network, but file, it's going to generate a file called, in this case, runfg_c, and it's going to place, it needs to call, it needs to know where to find the base Flightgear folder. In this case, you know, you can just click in here, right click, copy, and you would just paste it in here. That way the bat file knows where to find your base working folder for Flightgear. So we're going to close this. I'm going to close this one out because this one is no longer relevant. Here are an example. Here's an example of two different bat files. One is called laptop v1 HL20. The other one is called laptop v2 aspiration. Now, the reason they're different is they call different aircraft. I will provide a link. I'll provide a link to both. I also put in laptop because if I run this on my desktop, there's a different folder location here to find Flightgear. And so these are an example of the bat files. I should have showed you when that previous screen with the where you generate the bat files, there was a button that said generate bat file. Wherever your working folder is for MATLAB, that's where it will save the bat file to. So make sure you have this saved, or you know where you're saving it to. I've definitely done that several times where I can't seem to find where I just saved the folder to, the file to. So here I have a couple different examples, and I'll just go through some of the differences. So this is one thing you will have to do if you want to run these files, aspiration, etc. You need to go find your directory for Flightgear, and you're going to basically replace what I have as my working path to get to the various items, the data folder, then the scenery folder, and just pretty much go through, and anything you see that needs to be replaced, wherever there's this semicolon, that's where it's up to that point that you need to copy and paste the link from. So this would all be one you would need to replace with your working directory. Some of the things in here that make a difference, if I edit this name here and I put in space shuttle, or rather shuttle, or if I put in, you know, A380, it's going to call the A380 aircraft. So whatever you edit this name to, it's going to pull that aircraft. Some of the other things you can enable or disable. Freeze basically will, right now, you won't hear it, but I hear it occasionally. The tower somewhere over here, wherever the tower is, I think the tower is supposed to be over here. They will call to other aircraft because currently this is live, and you can tell because if I can get it to work a little bit, or it should be live. I apologize. Maybe it's just not rendering right now, but the windmills should be going. You can dictate again which runway, airport, but again, that's all going to change once you hit run on your Simulink model over here. So the only things that you really need to mess with, again, are the locations, and you do have to set that if you want this to run on your computer. Again, it doesn't matter what version is here. You just copy and paste your whole directory in after the equal sign, and that should be good. So those are some of that's how you change and edit the BAT files. This one's a little bit different. This one uses the aspiration aircraft. Everything else should be the same. In contrast, my desktop would basically be a slightly different. I think this is E drive instead of D drive. So again, you'll need to change it to match yours. Sorry for the cough. BAT files, models. All right, let's go through the Flightgear, and then I'll do Flightgear animations. Or let's go through Blender real quick. So in Blender, here's a model of our spacecraft. You can look up on YouTube how to install add-ons. If you want to build your own spacecraft or aircraft, you need to install this AC3D export add-on. It's already built in when you download Blender. Blender is free, costs nothing. All you really need is, I don't think you even need a Steam account, but if you have a Steam account, then just download Blender. It's free. It's an open source software for 3D modeling, animation. Very easy, very intuitive, and there's lots of tutorials. I won't go through how to use it, but with 30 minutes of tutorials, you can build something like this, and it's really easy and intuitive. So some things you need to do when you're going from Blender into Flightgear. Like I said, install this add-on. This is what you have to export it as for Flightgear. It requires a .ac file. So some other things, build your whole spacecraft, and each of these components has to be its own item. So here, if I clicked aileron left, you can see it highlights it. Aileron right, airframe, gear right, shaft, and you can't really see it right now, but if I rotate this by 90 degrees, you can see it's pointing down. So you'll need all these for setting up your animation. So real quick, I'll just do the walk through how to do one of them. So if I hit the backslash, that's going to isolate your view just to that item. I can hit tab to go into edit mode, hit 3 to go to front view. You can see the origin is here in the middle, and what you would do, let's say you have something else selected. I select the point I want, Shift S, cursor to selected. That moves this cursor, the 3D cursor, to that location. Then I hit tab, go back out, object, set origin, origin to 3D cursor. It's already there, so I'm not going to worry about it. If I hit tab, the next thing we need to do for animation purposes is we need 2 points along the axis that is this leading edge if we wanted to rotate along that. So it technically should rotate at some point just inside of that, right? If there was a hinge here, it would be rotating inside of it. I'm not that worried about moving it there, so I'm going to instead grab 2 points. This first one here, I'm going to hit Shift S, cursor to selected, and you see it shifted up there. Over here, if you're missing this window, hit N and it should pop up, and then it's just a matter of selecting whatever, in this case view and 3D cursor. You can get your XYZ position. I think you can see behind me. You should be able to see behind me. I wrote down on the board all of the positions for a whole bunch of nodes, or in this case vertices. And so here I wrote down the XYZ, and then I took the point opposite of the center origin, and I wrote down these values. So what that's going to do is provide 2 points on this axis. That's going to cause the rudder, in this case, to pivot around it. So that's everything in Blender that is kind of imperative to get a model working. Is one, you need this add-on to export. If you don't have that, you can't export a model to Flightgear. And 2, setting the origins and finding the locations of points around which you want to pivot. Okay, so that covers exporting and animations. Now when we come into back to this animation file, this was from here, animation models, aspiration models, and this is this XML file that's attributed to the Blender model here. So we come in here, and for example, I have for the nose gear, for the landing gear, I have a center. I use the center axis rotation type. So here the center is, I specify the location. So if I go in over here, I can grab the nose gear. It's the right gearbox. Here we go. Let's grab that. I'm going to hit backslash. Now you can see the origin is set right here, and it'll display the properties. So in this case, I need to, this one's slightly different, so I need to go into edit mode and show you how to grab this point. So if I grab both of those points, so right now I have 2 points selected, I hit Shift S, cursor to selected, it'll halfway divide. And if we look at the cursor, it's going to be 6.113, 0, and 0.003571. So this is the part that's a little tricky, and I couldn't find anything on YouTube on how to do this properly. So the X, when you export, oh, that's something else. When you export this, it's by default minus Z forward. You need to change that to Z forward for flight gear purposes. Leave the Y up, but Z forward, that has to be Z forward. So once you have exported this, if you noticed, this is 6.113. However, in the animation file, this has to be negative 6.113. The Y and the Z will stay the same value, I believe. And I'll just double check that here momentarily when we look at one of the other ones. But the X has to be opposite value for purposes of flight gear. You can mess around. The factor is how much it's going to rotate by when you enable the animation, and the offset is exactly as it says, how much it's offset starting. In this case, it starts 0, which is going to be horizontal, and when it's enabled, it's going to rotate by 90 degrees. In this case, it's going to rotate down, being positive 90 degrees. And it's going to rotate 0 around the X, 1 around the Y, 0 around the Z. So this uses the coordinate system of, I think in flight gear, X, Y, Z. And so this is the easiest way to do it for the nose gear. When we come down to let's do the right aileron. When we come into the right aileron, we'll take a look. Rudders, aileron left, aileron right. This is going to be for using the elevator, using the right aileron also in elevator mode. So in this case, we have differential elevons. The elevator works as an elevator and an aileron, and it works by first inputting the rotation for the elevator, because the elevator animation comes first in this file. Then you see you have the aileron. That's the property that it's controlling. Here it's the elevator position normal, and then so that's the aileron right. Aileron right again shows up for the aileron position norm. So it's first going to animate the elevator deflection. Then on top of that, it will animate the aileron deflection. And so this will enable them to operate differentially. So if we take a look here, the origin is going to be this value here. So let's come back up, aileron right. So let's take a look here. Again, this is the X location is minus 6.9 in Blender. It has to be positive 6.9. Okay, Y has to be opposite as well. So it's X and Y that have to be opposite. Y is negative 5 in Blender. We're at negative 5 in the Y. It needs to be positive 5 for flight gear. And then for the Z axis, this is positive 0.8. And it's going to correlate to these two values are actually the two values on either side here. So it's this value and this one here. So that's what these numbers actually correlate to. If you, for example, place the coordinates XYZ for this as your X1, Y1, Z1, and place these as your X2, Y2, Z2. And you have some rotation 35 that might be going up. If you flip these and you make them opposite, so this point becomes X2, Y2, Z2, and this becomes X1, Y1, Z1. And you do the same positive 35, it'll just be in the opposite direction because you're basically telling it to have Y going, the axis going in this direction versus this direction. And so it's just going to flip the direction of the animation. So that's one easy way to flip the animation if you're setting up your own animations. So this is often easier to do. Notice I don't have a center location. I'm just using an X1 and an X2, 2 coordinate points to draw the axis around which it's going to rotate. But it's imperative you have to flip the sign for the XY from Blender into your animation file. That covers everything for Blender. So I can go ahead and close this. Don't save. Close this out. Don't save. Now on to Simulink and again, sorry for the cough. Flightgear, a couple of things in Flightgear. One, if you go to View, there's this Earth View Orbital Rendering. If you enable it, it's going to look like garbage right now because I'm at ground level, but it will render the Earth as a whole view, external from space. So if you were like at 200 kilometers, it would basically give you cloud layer and give you the continents, and it looks okay for what it is. In this case, we don't need it enabled yet, but I will show you what it looks like once once we get up to altitude. Some other items on your joystick, if you're running my aspiration file here, your hat, if you have a hat button, this is going to control your RCS thrusters. So if you push up, notice how I'm changing the view in Flightgear. That's one thing I haven't figured out yet. So if you know how to do that, please feel free to leave a comment in so I can change this in Flightgear. But your hat will change your view in Flightgear. So it's slaved both to Flightgear for viewing control, but it's also slaved in Simulink as the RCS thruster control. So you can pitch down, pitch up by pulling back. If you go to the 45 or minus 45, that's going to be your yaw thruster control. And if you go right and left, that's going to be your roll control for thrusters. Your throttle is going to be the engine throttle. And other than that, it's just normal roll left, right, yaw, twist, and pitch up and down. So when using the RCS control, just realize you're going to be changing your view in Flightgear at the same time as you will be bursting. So it might be a little hard to control and visualize it at the same time. All right, let's go into Simulink. All right. Some important things in Simulink. If you have access to my aspiration team's data for our flight model, our aerodynamic model, you're going to have some matrices some multi-dimensional arrays. In here, you're going to need this, I think it's master of pulling all 6 elements, pull 3 def, and I think deflection data, as well as these couple of map files here. That will enable when you run, you first hit run, open aspiration setup v4, hit run. This will be available to everybody. It's going to run it. Currently, I have commented out down here. This right here, if you uncomment it, will run the Simulink model. The only issue with that is if you run it from the MATLAB code, you cannot stop or pause. You have to wait whatever this duration is here, 60, so 7 minutes. You have to wait the 7 minutes regardless for the simulation to time out in order to do something else. So I've just commented out here, and you can hit run and stop from within Simulink. It'll be a little bit easier. If you have, like I said, access to the map files, basically if you're on my team or Professor GTA, you'll have access to these aerodynamic models, in which case you can leave everything as is. You also have access to these up here, the CLCD files for lift and drag, which output to down to here. All this stuff will get cleaned up, so if it doesn't look the same at the point when you are downloading these files, if it looks different, you'll just have to find your way around. I'm going to go through over the next couple months, clean it up, improve some things, etc. So if you have access to those multi-dimensional arrays, you don't need to do anything with them. Otherwise, you'll need to come in here and you have CX, CY, CZ output that are currently going to these terminators. You'll need to stick these into these 3 ports and just disconnect these and pull them off to the side. This right here utilizes the HL20. It's a modified HL20 subsonic aerodynamic model. It goes through and calculates everything based off of alpha beta. I had to modify a few things to make it controllable, in particular for CL, CM, and CN. Everything else, CX, CY, CZ is as initially designed. So again, if you're running it with access to the multi-dimensional arrays, you don't need to change anything. Otherwise, you'll need to change those input connections. As far as using multi-dimensional arrays, it was a little confusing trying to figure out which of the blocks I needed. So I'm just going to run through real quick how to do this. If you have a multi-dimensional array, in this case, this item CX, I'll just show you real quick. So in the run file here, you'll also get flagged if you don't have access to these when you get to here. It's going to load these elements, these 2 map files. If you don't have access to these, it's going to flag you. Just comment these out and don't worry about it, and make the changes in the Simulink file, like I said. As you do, and you run these, you're going to see that they're going to show up as multi-dimensional arrays here. These multi-dimensional arrays are sorted by these components here: Mach, altitude, alpha, beta. I believe it's by kilometer for altitude. Yeah. So input here is in meters. That's why I'm dividing it by 1,000 to get kilometers. The multi-dimensional array. If I go into the properties, also this is the N by D lookup table, is what I used to implement this. So if we look at some of the stuff in here, it's a 4-dimensional table. Then the 4 elements that are going to go in are Mach, altitude, angle of attack, and CFX, which is the CX. I think that's supposed to be the output. I apologize. I don't actually. Oh, beta is the last one. CFX is the output. That's right. This is that's right. This is calling the workspace. So if I move this over here, come back to MATLAB and we look for CFX, it's this multi-dimensional array. So this is the multi-dimensional array you want to call the table data. Your breakpoints represent what the 4 elements of the array are. So in this case, Mach, altitude, AOA, angle of attack, and your side slip angle. In this case, the table is set up for degrees, so the radians need to be converted through this radians to degree. So this is how you set this up. So these inputs here become the inputs on the block itself. So that's setting up lookup tables. If you have your own data, and as a quick note, if you want to build your own similar table for your own aircraft, if you're building one, the easiest way to do this is VSP Aero. I'll provide a link to it. It's also free, open source. And you would basically just do a sweep of alpha, beta, Mach number, in this case, altitude, if you wanted to set it up exactly the same here. And you would just take all that data and export it out of VSP Aero, bring it into MATLAB over here, and you would need to build a 4D, 5D, 3D, whatever size array you want for whatever you're doing. And that's how you can build these multi-dimensional arrays. And there's enough YouTube videos showing VSP Aero and building multi-dimensional arrays in MATLAB. But that's how, brief walkthrough, you could do it. Other than that, some other items here, centrally located in the whole model. Again, this is everything's just one giant open. I'm going to go through over the next couple months and clean it all up. But here we have access to 2 items. Currently, brakes are not enabled, so don't use this switch. The gear handle is enabled. There's also one other way in which it is enabled. Down here, this is our input, pilot input section. So this ground elevation, the altitude within Flightgear, this is Mojave Spaceport, Aaron's Spaceport. There we go. So the ground elevation starting is 800 and I think 46 or 844, something like that, maybe 54. So I set it to be 100 when you're less than 100 feet above ground. The landing gear will be enabled, and when you go above 100 feet below ground or above ground, it'll automatically retract. You can manually turn on the flight gear, turn on the landing gear here with this button while the simulation is running. All right, so now to some of the simulation stuff. Go ahead and do a quick test flight and show some of the animations and the landing gear. So let me change my view here to chase, get set up. When I hit run, it's going to compile. Since it's, I think, running the first time, it's going to take a little bit longer, perhaps. I'm going to lower my throttle to 0. The initial conditions have a slight forward velocity. You can see that there's clipping through the ground. There is no interaction between Flightgear and Simulink. It's just Simulink to Flightgear. So I'm going to start pitching up. Oh, this is not the view I wanted. Oh, this one's awful to be in. There we go. All right, you can see the landing gear has retracted. If I want to put it down, I can. Go through some of the animations real quick. If I yaw right, you can see pivots. If I roll right, roll left. All right, I can pitch up. And I'll finish pitching up. Right now I'm not going to be climbing very fast. I am full throttle, never mind. It's going to be a little glitchy here because one, I'm recording, two, this is a really old computer. It's like a decade old, so it's a little slow at times. If you want to view some of your elements while you're flying, such as altitude, thrust, etc., come over here. These are all scopes, which I'm sure you're familiar with if you have MATLAB and Simulink. You can open them. In this case, altitude should already be set up. For auto scaling, yep. So you can see burnt out of fuel already, and we're reaching altitude of like 3,000, mostly because I flew out, not up to start. I can close that. I don't need it. So that's some of the control stuff. It's going to be, depending on the quality of your computer, it can be a little glitchy. So can also, in my case, make it really ridiculously hard to fly when it's just so laggy and really low frame rate that something you input happens 5 seconds later. So you can see there's the airfield. I'm going to go ahead and stop the simulation. And let me see if there's anything else that I need to go through. Guess I can go ahead and show. Let me open the altitude back up. Try and run it. See if I can hit 100 kilometers this time. I hit run. It's gonna reset over here in flight gear. So let me get positioned next to it. There we go. All right. We'll watch our yeah, this is chugging hard. So for us to make 100 kilometers, I need to generally conserve fuel initially until we get high enough elevation, 15 to 20 kilometers, and then go full throttle when density is low enough. Try and stay subsonic beforehand. That'll increase mass flow rate once we get up here, and less altitude, less drag, punch through the wave drag up to like Mach 1.5, and it drops back down significantly for our spacecraft. And above 20 kilometers, there's significantly less air drag, skin friction drag. So we'll punch up here. You can see it's still a little laggy. I'm trying to rotate and it's trying to catch up. So once we hit about 50 kilometers, I'll switch over and show you the Earth view. So it looks like we burnt out maybe somewhere around 40 kilometers, 35, 40 kilometers. So if we go into view, oh, there we go. Yep. View, Earth view, orbital rendering. It's going to be a little glitchy here for a second. I hit start, and it's going to take a little moment to load, and still yet is a little struggling. Oh, there, yep. Okay, rotated too far. So you can see kind of does the whole far view of the Earth. Looks good-ish. You know, way better than the built-in MATLAB visualization, which is awful looking. Bare bones. Bare bones is really what it is. So coming up, looks like we're about to reach. If you demonstrate, so right now you can see no effect from any inputs, but if I pitch down, you'll see it's going to pitch down here, but it also changes the view, right? I'm pitching up and it's changing the view. So like I said, if somebody knows how to fix that or disable that slave value here in Flightgear, that would be awesome. Please leave a comment so I can change that. So if you want to roll, again, I'm using the hat right. It also forces the view to change. Whew, this is so slow and buggy. There we go. Go back up. Makes for very challenging flying. Okay, try and zero it out. This definitely gave me a newfound level of respect for pilots when they are doing this, especially for the gentlemen who have been flying the Spaceship Two on these very short, fast flights to space, because you really have very little time and everything happens very quick in one small input, and you will just keep turning and turning. So it's a very, very awesome proficiency that they all have. So, and the men and women who've flown the space shuttle and other spacecraft. So we're going to, at about 70 kilometers-ish. I'm going to turn off the Earth view. Go stop. You can see it goes back to trying to render the ground, and which is why you don't see anything outside of something like a, I don't know, 150 kilometer area. Just trying to rotate the view. It's very laggy and extremely bad frame rate. Hopefully it doesn't crash. Here's where we took off from, down here. And maybe it's going to crash here in a second. Nope. Okay. So I'm going to start pulling back. I recommend having your alpha up so you can see where you are with your angle of attack. Whew, this is oh, there we go. It caught back up. So it looks like we're somewhere around 10,000 meters, 10 kilometers, flying past over the airport. So I think that is everything from downloading, installing, setting up the BAT file to run on your computer. All these files will be available with the exception of, I should just go ahead and pause the simulation. All these files will be available with the exception of, like I said, the 2 MAT files, since I did not produce those. That was from our aerodynamics team. Rest of this was generated by myself, so it will be available for anyone who wants to learn how to set up a Flightgear, Simulink to Flightgear simulation, and kind of the different components. So I don't think there's anything else. Feel free to rip apart, digest, edit, change. Over time, I'll go through and make some changes to these. So depending on when you watch this and or download the files, you might see something different or changed or edited or commented out, or, in extra included features. If you do not have access to these 2 files, no worries. Just simply comment these 2 lines out, and like I said, oh, come on. Minimize that. We'll come into the Simulink file. You'll need to, like I said before, come down here. CXCYCZ, need to plug into CXCYCZ. That will fully enable the modified HL20 subsonic aerodynamic model. Everything else will work. When you want to run, so if we do this from the beginning, when you have everything installed, the process for making this run is first open MATLAB, open the aspiration setup v4. Then you need to go and open the aspiration sim v4. That's going to be this file. If you don't have the aero data, again, make these 3 connections over to here. Then you will also have access to these 2 files here. One is aspiration. You can run it. You'll have access to the aspiration model, the 3D model. You'll also have access to this HL20. For the HL20 to work, you need to go through and install the HL20 file, which again, recap, is provided here. Just copy and paste this in here, following the instruction. There's enough YouTube tutorials on how to do that. So if you want to run the HL20 version of this, all it does is simply change what you're looking at. If you want to look at the HL20, then run the HL20. If you want to look at the aspiration, run the aspiration file. That's really the only difference. There are some slight animation differences because the HL20 has the flaps on top and bottom, so that's really the only slight difference. I think that is everything. So any questions, please feel free to leave them in the comments. I'll take a look, or if you know how to message me directly on Teams, message me on Teams, and I will get back to you as soon as possible. So thank you. Hopefully this helps anybody who's trying to build their own simulation, their own model, build their own aircraft, because this was not a simple process, and the information how to do this whole process was all over in several different videos. And reminding of that, there is okay, I just need to do this. Couple of things that I would like to provide links to, but also give a shout out to for being awesome. One, VD Engineering, you're a lifesaver, so thank you. Please check out his YouTube page. He's got awesome, amazing videos on Simulink, Flightgear, meshing of the two. It's great. Also, Christopher Lum, outstanding gentleman and professor, one of the best people on YouTube, amazing lecturer and videos, great guy, some awesome videos. It was because of him I even started learning how to use Simulink. So thank you, Christopher, and thank you, Desh. And one more, good tutorial that helped me get started. I still had to figure out a couple things like the -X, -Y for the animations, but check out this video, Flightgear Animations, how to axes and origins. And as well, I'll provide a link to this one. Oh, that same video, never mind. So with that, I don't think there's anything else that I needed to cover, but again, if you have questions, feel free to leave comments or message me on Teams. And thank you. Have a good day.